Solve the absolute value inequality. Absolute value of 2x minus 4 over 3 is greater than or equal to 2. Whenever you see an absolute value in an equation or an inequality, remember we're going to break this into two cases. The first is when the inside is positive, non-negative. This means we can drop the absolute value and we get the inequality 2x minus 4 over 3 is greater than or equal to 2. The other scenario is where the inside is negative, in which case the absolute value will negate. So we've got negative 2x minus 4 over 3 is greater than or equal to 2. We'll solve each of these new inequalities and then put the two solutions together. On this first equation, we need to get x by itself. Let's get rid of the fractions first by multiplying both sides of the inequality by 3. Now, since we multiplied by a positive number, this will not affect the direction of the inequality. On the left, the 3's reduce, and we're left with 2x minus 4. On the right, we multiply together, and we've got 6. Next, to get x by itself, let's get rid of 4. We'll add 4 to both sides of the equation. This leaves us with 2x is greater than or equal to 10. And then finally, to isolate the x, divide both sides by 2. Since what we're dividing by is not negative, this won't affect the inequality, and this will leave it as a greater than or equal to. So we get x is greater than or equal to 5. Let's now solve the other half of the problem. We're going to start this the same way. I want to get rid of the 3 and the negative sign. So let's multiply both sides of the equation, the inequality, by negative 3. On the left-hand side, the negatives are gone, the 3's reduce out, we're left over with just 2x minus 4. This inequality, because we multiplied by a negative, will switch direction. So this becomes less than or equal to. We multiply 2 times negative 3, we've got negative 6. Still getting x by itself, we're going to get rid of this 4 by adding 4 to both sides of the inequality. So on the left, we have just 2x left over. On the right, we combine like terms and we get negative 2. Finally, divide both sides by 2 to isolate the x. So on the left-hand side, these reduce, leaving us just x. On the right, these reduce, and we've got negative 1. Note here that even though there was a negative number involved, what we divided by was not negative, so we did not switch the direction of the inequality. Now, putting these two together, we can graph this on a number line. The only points here that I'm going to label are x equals 5. This came from the first inequality. And we have x is greater than or equal to 5. So I'm going to draw this bracket here and shade in everything to the right on the number line. Over on the left, we've got x is less than or equal to negative 1. So less than or equal to, because we have this inequality here, this equals part, I'm going to use the square brackets. X is less than or equal to negative 1, so we shade in everything to the left. So now we have the graph and a solution to our inequality.